Alright, so we're going to do a quick video about drag. You should have already, or you can still, watch a video about, I think airfoils is where we first introduce the induced type of drag. And there was another video that we talked about it as well briefly, probably in the 4 forces of flight. So we're just going to specifically talk about drag in this video, but we're not going to go into great detail about the induced type of drag. We'll just briefly touch on it since we already talked about it in a couple other videos. But the other type of drag is going to be the parasite drag. So if you think about what a parasite is, something that latches on to something and holds on for dear life. So the different kinds of parasite drag are form drag, interference drag, and skin friction type of drag. So let's think about what those are. The form drag is going to be the most common thought type of drag. So here's a little Cessna 172. It's missing its nose gear, but that's okay. So here we go. We have this little guy here. So if you look at the shape of him and how he was created, how he was designed and all of that fun stuff, we've got these little wing struts down here to hold on the wings, and we have probably a couple little antennas sticking up somewhere and a few other little things. So as this aircraft goes through the air is going to hit every single part of this. Obviously it hits across the top of the wings and creates lift and all this other stuff. But these wing struts here, they're just going to get in the way. So this would be considered a type of form drag. It's like when you stick your hand out the car window and you decide to put the flat side of your hand out, the air is going to hit your hand and blow back, creating a lot of drag simply based on the form of, or the shape of, what's going in front of it. So there are a lot of little things that create quite a bit of drag that's form drag, just based on what they put on the airplane. Let's say you decide you like to film all of your flights in your little GoPro or something hanging off the outside, which some people do. Well, that's going to also be a type of parasitic drag. So form drag is based on the shape of the airplane. The next is interference drag. Now, as we talked about with the airfoil and with the air molecules and the control surfaces, air flies over the top of all of this, and it creates different pressure systems, and then the air is going to flow in different directions. So interference here is going to talk about the airstream of the air that flows maybe over the wing, over the fuselage, down this wing strut, wherever it's flying, right? The air goes, and then they might meet each other. Like this flow of air might meet something that's on the tail, for example. Or right here on the fuselage, you have air coming under the wing, and then it might meet up with something else on this part of the fuselage, and where they meet, the two airstreams are going to meet, and that will create drag, because it's no longer being efficient. It's like smacking into each other. So when you design an airplane, not that you're designing one, but when somebody designs one, and the air goes around it, they need to make it so it's efficient, so when the air goes in all the different directions, it doesn't run into each other and cause the plane to be held back. Skin friction, it's similar to form drag. I always think they're kind of the same type of thing. But the big difference is that this is more on a molecular level. If you were to take a microscope and look at the airplane, no matter how clean it looks, no matter how smooth it looks, there's going to be some tiny, friction involved. Some planes it's more obvious. Maybe they're fabric. Maybe they have rivets that you can see. But maybe it's less obvious. Maybe you're in a, polyfiber style, smooth, sleek aircraft and it's beautifully painted and clean. But if you were to take a magnifying glass or a microscope and look really closely, there would be little nooks and crannies, and the air molecules will actually get caught up in that. There's like a layer that will get caught up in that. So at the molecular level, the skin texture will actually cause the aircraft to be slightly less aerodynamic. There's not a whole lot you can do about it other than keeping your plane clean and sometimes like what the aircraft is made out of. So those are the forms of parasite drag. The induced drag, as we talked about before, has to do with like downwash and vortices, where it's anything that when lift is created, there's also drag that's created. So that's going to be the induced drag. So the interesting thing about these is that they don't behave differently, or they do behave differently, they don't behave the same. So as airspeed increases, so we're going to have this plane, and it's going to start going faster and faster and faster. as airspeed increases, all of these types of drag, this parasite drag, the form, the interference, and the skin friction drag, they are all going to also increase. You're going to face more of this type of drag the faster you go, okay? However, induced drag, the faster you go, the lower induced drag becomes. So when you're starting off down the runway and you're speeding up and you're speeding up and you're speeding up, what's happening is you have a very low parasite drag at that point in time because you're not really moving very fast. So all these antennas sticking up and anything else going on here, it's not really causing that many problems because you're not going very fast yet. Just like if you stick your hand out the car window at 1 mile an hour, doesn't matter what direction you put it, it's not going to do a lot. The faster you go, the more it's going to cause your hand to fly back. Now the induced drag, on the other hand, as you start going down the runway, you start off with a really high induced drag. As soon as you start producing lift, like at first takeoff, you're producing this lift, and as soon as you start producing that lift, you have a lot of induced drag, a lot of it, but you have very little parasite drag. And as you get faster and faster and faster, this starts to go down. Your induced drag starts to go less and less and less, yet your parasite drag starts to get higher and higher and higher. So there comes a point when you're at the most efficient, when your total drag is the least. It's when your amount of parasite drag and your amount of induced drag kind of overlap, like kind of cross each other on the graph. At that point, you're going to be acting the most efficiently. You'll have the least amount of drag because, you know, you won't be getting extra parasite drag and you won't be getting extra induced drag. You'll have both kinds, but it's the best place to be. Another thing about drag that's important to note is that it's related to, as I just mentioned, your speed. So the type of drag and the amount of drag is going to be related to your speed. Your drag, like on a graph, when you try to find out like your lift and drag ratios and all that, you'll notice that both lift and drag have the same concepts. So speed is one of them. Surface area of the wing, which is simply, literally, the surface area of the wing. Bigger, smaller, that's going to make a difference. Air density, well, what does that mean? Well, that has nothing to do with the airplane. That has to do with the environment that you're flying in. So that's going to make a difference. And then the coefficient. So each wing is going to have its own coefficient of lift, for example. It's also going to have drag. There's going to be a drag coefficient. You don't have to know what it is. You don't even have to understand where it came from exactly, but you have to understand there is a coefficient of lift and a coefficient of drag, and both lift and drag are based on the same set of ingredients. They're based on speed, surface area of the wing, air density, and their coefficient. Okay, so why am I bringing up lift with our drag conversation? Well, so there's this thing called the LD max. At the LD max, you're going to be getting the most lift for your drag. As we talked about, as you speed up, you get more parasitic drag. As you speed up, you get less induced drag. And there's a point when you get the most bang for your buck by overlapping the two where you have the least amount of drag. But there's also a thing where you get the most lift for your drag. So this is important, especially if you lose your engine and you're gliding, for example. You know, knowing what speed you need to be going could be important, things like that. So the most lift for your drag is going to be the most efficient way of flying, and that's going to be your lift per drag, your LD max, which you can find on a graph, which is usually shown with your drag and your lift. If you want to learn more about that and see the charts that I'm talking about, you can open to chapter 5 of your FAQ, and it has several charts. I can actually show you really quickly. You probably won't be able to see it, but right here, there's kind of what a page looks like here in this book. So your total drag, for example, where it's the lowest, is where, as I said, the induced and the parasite intersect with each other. So knowing what that airspeed is going to be very useful for you to know when you're going to be flying efficiently. And on the same concept, if you are gliding in an emergency, knowing your LD max is going to be important. That's simply the highest point on the graph, but what it means is when you're getting the most lift for the amount of drag that you're taking on. So let's say you lose your engines and you needed to make an emergency landing. okay, so what angle of attack do I need to be at? What speed do I need to be at? How should I configure my airplane so that it will glide farther so I'm not getting drugged back and I'm not losing all my altitude? So that's kind of why you need to know this stuff. But the other thing is that it probably will be on your test. So understanding that parasite drag increases with airspeed, induced drag decreases with airspeed, and there's a point where they overlap, where is going to be the best place to be, and that also lift and drag are very similar. When they are calculated, they involve the same ingredients, which are speed, surface area of the wing, air density, and their coefficient. And the LD max is your most efficient place to glide. So hopefully that explains a little bit more about the drag situation. As I said before, that's what counteracts thrust in the four forces of flight, and check out that video if you didn't already for that particular concept.